Dear students, in this video we are going to study the topic representing graphs. Okay, so there are three ways in which you can represent a graph. Okay, first one is adjacency list. Second way of representation is adjacency matrices or adjacency matrix, and third one is incidence matrix. Okay, so adjacency list, adjacency matrix and incidence matrix, these are the three ways in which you can represent a graph. Okay, so what is adjacency list? Adjacency list is the representation of neighbors of each vertex in a graph. Okay, so in adjacency list we list the vertices which are neighbors of a vertex. Okay, second one is adjacency matrix. In adjacency matrix, zeros and ones are used to indicate whether the pair of vertices are adjacent. So if the two vertices are having an edge, so we represent it with 1, and if edge is not there, we represent it with 0. So this is the representation of neighbors of vertices in a matrix form. Third one is incidence matrix. In incident matrix, we indicate whether a vertex is incident to an edge. Okay, so if a vertex has that particular edge incident on it, we check these things. Okay, so consider this example. Okay, in this example, we can see there are four vertices: vertex A, vertex B, vertex C, and vertex D. Okay, so we have to check whether these vertices are neighbor to each other using adjacency list. Okay, so we will write here adjacency list for vertex A. So for vertex A, the adjacency list goes like this. How many edges are there for vertex A? 3 edges, but we have to see the neighbors. So B is one neighbor and C is another neighbor. So the neighbors are B, comma C. Okay. So this is adjacency list for A. For B, the adjacency list is to vertex B. A is a neighbor and D is a neighbor because both of them are connected by edge. So for vertex B, we are having A and D are the neighbors. Okay. For vertex C, the neighbors are the connected edges. For vertex C, A is connected and D is connected. Okay, so for vertex C we are having A and D are connected. Okay, and for vertex D, the adjacency list is for vertex D, C and B are connected. So B and C are the neighbors of vertex D. So for all the vertices we have drawn we have listed here the neighbors. That is called as adjacency list. Okay. Next is adjacency matrix. In adjacency matrix, it is between the pair of vertices. Okay, so representation of neighbors using pair of vertices using matrix. Okay, so we'll draw adjacency matrix. So as you know, we write here the vertices. So A, B, C, D are the vertices. Here so A, B, C, and D. Okay, so we'll check if A to A connection is there, no, so 0. A to B, A is connected to B, so 1. A is connected to C, yes, so 1. A is connected to D, no, so 0. Okay. B is connected to A, that is B to A connection, yes. B to B, no. B to C, no. And B to D, yes, B is connected to D. Okay. Then for C, C is connected to A, yes. C is connected to B, no, so 0. C is connected to C, no, 0, and C is connected to D as 1. So D is, whether D is connected to A, no, 0. D is connected to B, yes. D is connected to C, yes, and D is connected to D itself. So here we are having a loop. Okay, so this is self-connected. Okay, so this is the adjacency matrix. So adjacency matrix is very easy. We have to check whether the neighbors are, the pair of vertices are neighbor of each other or not. Okay. Then comes incidence matrix. In incidence matrix, we check whether a vertex is incident to an edge. Okay, means there is a relationship between vertex and edge. So here what we represent in matrix, we represent whether a vertex is incident with that edge. Okay, so we will draw the matrix. So here it will be the vertices A, B, C, D. Four vertices we are having A, B, C, D, and here you will rename the edges. Now go to the figure and rename name these edges. Like this is edge 1. Okay, you can give randomly the numbers to the edges to remember them. Okay, so let's say this is edge 1, then edge 2, this is 3, 4, 5 and 6. So we are having 6 edges in our graph. Okay, so using edges you can now join the vertices. Okay, so this is not, these are not the weights, these are the numbers just we given to the edges. Okay, so we have to check with, now here we will list here edges 1, 2, 3, 4, 5 and 6. Okay, so these are the edges and all these are the vertices. Okay, so incidence matrix is the relationship between edges and vertices. So we have to check whether this vertex A is incident with edge 1s. So edge 1 is incident on vertex A. So here we will write 1. Okay, then A is connected by vertex, A is connected by edge 2s. So we will write here 1. A is incidence on edge 3s. So A and H4 there is no connection, so write 0. 5 is not connected, 6 is not connected. Then for vertex B, check in figure for vertex B. How many edges are incident on vertex B? 1 and 5. So 1 here and 5. Others are not incident on vertex B. Then go for vertex C. For vertex C, how many edges are connected to vertex C? 2, 3 and 4. So we'll write 1 only in the column entries like 2, 3 and 4. Okay, others are 0 for C. Okay, and for D, edge 4 is incident on D, edge 5 is incident and edge 6 is incident. Okay, so for D we will write 1 here for 4, 5 and 6. Okay, all others are here 0, right? So this is called as your incidence matrix. Okay, now few observations you can make. Before that we will again revise. Adjacency list is neighbors. We are checking the neighbors of a vertex. In in adjacency matrix, we are checking if the pair of vertices are neighbors of each other or not. So we have written 1, right? And in adjacent matrix we again can find, like suppose if you take this one as an example, so you will get to know that vertex A and vertex B are neighbors of each other, right? Vertex A and vertex B are neighbors of each other, right? Now few observations we can make here, like here you can see. Now see, first observation is two columns for incidence matrix. Why we use incidence matrix? Two columns have identical entries, then multiple edges are present in the graph. If two columns of incidence matrix are having identical entries, then we can say that multiple edges are present in graph. Okay, so representation of multiple edges. So tell me if multiple edges are present in this graph or not. Yes, there is a presence of multiple edges in the our graph. Okay, so from column we can check this column. In incidence matrix we will check that column 2 and column 3 are having unique entries. Okay, you can see column 2, that is 1 0 1 0, and column 3 is having 1 0 1 0. So you can see column 2 and column 3 in incidence matrix are having unique entries or similar entries 1 0 1 0. So here you can see that the edge 2 and 3 are multiple edges. So in figure you can see edge 2 and edge 3 are multiple edges. So we call it as a multigraph. So these are multiple edges. So Incidence matrix is used to detect the multiple edges if columns are having identical entries. So 1010 1010 was the identical entry for column 2 and column 3. Okay, one more observation you can see here. If a column has exactly one entry which is equal to 1, so then the loop is present in the graph. Means if column is having only one entry and that entry is 1, then it is a loop. So you can see here, you can check incidence matrix. Column 1 is not having single entry, there are double entries. Column 2 is also having two ones. Column 3 is also having two ones. Column 4 also has one twice. Column 5 also has one repeated. But if column 6 has only one single entry. That entry is 1. Okay, so here it is single 1 present in column 6. So you conclude that age 6 is forming a loop in the graph. So go to the figure and you will see that age 6 is forming a loop at D. So where the loop is there? At D vertex. So if you join this line and this line, you can see here there is a presence of loop in the graph at vertex D, and the age number is 6. Okay, so these are the differences between adjacency list, adjacency matrix, and incidence matrix. So remember, incidence matrix is used to identify multiple edges in the graph and to identify loop. Hope you understood this topic. Thank you.